Hey everybody, today we're going to talk about the vertex form of a quadratic a little more. We're going to focus on how we can perform transformations in this form of a quadratic. So in order to do this, we need to remind ourselves what a parent function is and talk about the parent function of a quadratic. So the parent function, if we don't remember, this is the most basic, it's the simplest function in a family of functions. So like when I say family of functions, I mean like if we're dealing with a linear function, the most basic linear function would be y equals x. That is your parent function here. That is the most basic of linears. You could add something on at the end, but that's going to be what we call a transformation. It's going to adjust the function a little bit. You could change the slope, and that's going to adjust the function. But the most basic is y equals x. Another parent function that we had was y equals a and then b to the x. And this was our parent function for the family of exponentials. Remember, we could always add something at the end. We could add or subtract up here in the exponent, and that'll adjust our function. But this was the most basic. For quadratics, now we have that x to the power of 2. The most basic is just y equals x squared. Y-intercept is 0, the b is 0, the a is 1. Now we could add something, we could, add plus 2x, and that's going to adjust the function in a certain way. But the most basic, the parent function, is y equals x squared. All the transformations we do will be in relation to this function. So let's talk about some of those transformations. We're going to look through a lot of them today, and they're all going to be certain parts of this equation. This is why we like vertex form, because transformations are a lot easier to do in this form. So, the first one we're going to talk about is a translation. So all these transformations, they're going to adjust a graph somehow. And a translation, let's say we have some quadratic, nice parabola like this. A translation, all that's going to do is it's either going to shift it left or right or up or down, but this shape is going to be the exact same. So it would be like the exact same shape, but it's just going to, it's just going to go over maybe to the right. That would be a translation of 1, 2, 3, 4, 5 units to the right. Or maybe it went down and then it would look something like this. That would just be a translation of 1, 2, 3, 4, 5, 6 units down. And you can go to the left or right, up or down, or you can do combinations. Those are what translations look like. And when it comes to our equation, the two things that tell us what type of translation we have are right here. Our h is going to tell us the horizontal translations, how far left or right you're going. So h, I'll color code in red, is going to be our horizontal translations. So if we're moving left or right. Again, and that's in relation to the parent function. So that's what our h is. And our k is going to tell us how far up or down we've gone if we're doing any sort of transformation here. So this will be a vertical translation. And we'll look at an example of this. We'll graph both and we'll see. And this still is going to be our vertex. That's going to tell us, but it's also going to tell us any type of translation. The next type of transformation that we're going to see is called a dilation, and we talked about these a little bit yesterday. A dilation would be like, let's say we have, this is our parabola. A dilation can do one of really two things. It can make the graph more narrow, or it can make the graph wider. So a dilation that's going to make the graph more narrow would look like this. See how the blue graph is going up a lot quicker than the black? It's more narrow, has a steeper increase, and this is going to be affected by your a value. So the blue graph is actually going to be what happens when a is, the absolute value of a is greater than 1. So it's going to increase at a faster rate. It's going up quicker. What we also could have is a graph that ends up being wider, which would look something like this. It's still a parabola, it's just a wider parabola. And that's going to happen when your absolute value of a is less than 1 and greater than 0. Absolute value still will be greater than 0. So like 1/2, 2/3, 3/4, those type of values, the graph will become wider in comparison to that black graph. And these are called dilations. So they're either making it go more narrow or making it go wider. That's what dilations look like. And that's going to come from your A. So again, your A, it's actually going to give us a few things. It's going to be a dilation, and it'll either make it wider or it'll make it more narrow. So we'll say when absolute value of A is greater than 1, it becomes more narrow or narrower. And when the absolute value of A is less than 1 or greater than 0, then it's going to become a wider graph. So those are two of the things that A can tell us based upon just the number that we have here. Now if we look at A and we look at the sign of A, so let's say we have this graph right here, and let's say A is a negative value. So negative value, if this is our original, if we took a negative in the front, all it's going to do is it's going to make us open downward. Remember, when that A is negative, it'll open downward, and we refer to this as a reflection. So this graph down here is just reflecting over. That's what happens when A is negative. And again, this is in relation to that parent function. So if A is negative, so if A is less than 0, then we have a reflection. If A is greater than 0, then it's not a reflection. It's going to stay as an upward opening parabola. So these are the transformations we're going to look at. And again, they're all in relation to that parent function, that f of x equals x squared. So the first one we're going to look at, if you want to write all these down, that'll be really useful. I'm going to erase so I have room. So our first function that we're looking at, we have g of x is equal to x minus 3, that quantity squared, plus 2. And we want to know what transformations this goes through in comparison to that f of x equals x squared. So this is f of x equals x squared right here, and we want to know what this is going to go through. The goal is going to be to figure it out just by looking at this and not having to graph and check, but we'll figure it out by looking, and then we'll check the graph to see. But the goal is being able to tell just by looking. So the transformations this goes through, well, if you look at the A, it's just a 1 here, so that means there's not a dilation, and it's a positive 1, so it's not a reflection. So there we go, there's no dilation, there's no reflection, but there are translations. So there's a translation, and if you look at the 3, that means we're going to go 3 units right. 3 units right. And we're going to go 2 units up. If we were to graph this function and kind of compare, this would be g of x. If you're just graphing g of x here, your vertex is going to be right here. Then we can substitute some values in. We have x is 3, so we'll choose 4 and 2. If you put a 4 in, you get 1 squared plus 2, so you get 3. Through symmetry, we have both of these points. And if you put a 5 in, you get 2 squared, which is 4, plus 2, which is 6. So here, your axis of symmetry would get us right to 1, 2 over here. So your graph would look like this. I don't want to overlap, so I'll just leave a little space. This blue one would be g of x. So the transformations are, we went over 3 units to the right, 2 units up. That's how this compares to the original f of x function, to the parent function. It's the same exact shape, but it just got translated up over there. All right, our next one, we have the function g of x again. So we have g of x is equal to negative, then x plus 5 all squared. So by looking at this, well, if you look at A is a negative 1, so there's no dilation. Absolute value of A is equal to 1. But it is negative, so that means there's going to be a reflection. So there's a reflection. And also you have the plus 5 here, so that means there's also a translation. And the plus 5 means it's going to go 5 units to the left. So 5 units left. So we're going to reflect, and we're going to go with 5 units to the left. That's all we're listing in relation, but if we were to graph this so we can see what it looks like, your vertex would be at -5, 1, 2, 3, 4, 5, 0, because you have a plus 0 here, so your horizontal translation would be 0. And then if we just plug in some more points, let's say we did -4. If you put -4 in here, you're going to end up with a 1 squared is going to be 1, but it's a negative. Negative's on the outside of the parentheses, so it would be -1. So at -4 you get -1, which also means -6 you get -1. And if you were to put a -3, you would end up with +2, which is squared, is 4. But you take the negative, so -3 would go down to -4. Use your axis of symmetry to get another point, and that's what we're talking about with a reflection, is we're going to open downward like this. So this would be our graph. We've gone 5 units to the left, and then we reflected over. 5 units to the left would look like this in green. Would look like this. But then we had to reflect over because of that negative. So this is the final image right here in orange. 5 units left of a translation, 5 units left, and a reflection over that x-axis. Alright, so we're going to do 2 more. And again, these are all in relation to our parent function. So our next one, and this one we're going to just not do the graph, not use the graph at all. Our next one, let's take this away. We have g of x is equal to 1/3. There's parentheses around it. Parentheses don't have to be there though. 1/3 x squared plus 2. And we want to know how this compares to f of x equals the parent function x squared. So first thing we want to look at, your a value is 1/3. That is positive, so it's not going to be a reflection, but it is going to be a dilation here. Since the absolute value of a is less than 1, the graph, or the parabola will become, and we should say wider here. It's going to be a wider parabola. And then we're also going to translate. Well, there's nothing being added to x, like it's not like x plus 1 squared like that. There's nothing in there. This represents there being a 0 there. So there's no horizontal translation, but there is a vertical, so we translate 2 units up. So these will be the transformations taking place. We should have a wider parabola, and we're going to translate 2 units up in comparison to this parent function. Alright, our last one, you can try some of these on your own. We have g of x equals -2 times the quantity x plus 2 squared plus 1, and we're comparing that to the parent function f of x equals x squared. So there's a lot going on with this one. Let's look at a. We have a negative, so there's going to be a reflection here. And it's a 2, so it's going to be a dilation. The parabola will become, we're going to become more narrow here. So we're going to become more narrow, we're going to reflect, and then we also have translations going on. So we will translate, we're going to go 2 units to the left, and we're going to go 1 unit down. So those will be all the transformations for g of x in comparison to the parent function. Key things here are just knowing what each part does in vertex form and being careful with the signs, just like yesterday with the vertex. It's the opposite sign that we have here because it's x minus your h value. So this is like minus -2, so it's like a -2 there when we're talking about the translation. So just be careful with that sign. This one's a little bit easier to tell the k at the end. So go ahead and try some of these on your own, guys, and have a nice day.